Okay, now to start with a RCC project. So first select the grid, beam grid. So we'll edit this grid because we need to draw a top view. So we'll create the grid in XZ plane and we'll edit the grid as per the dimensions of AutoCAD plan. So in X direction it is 12 meter and in Y direction it is 15 meter. Okay, now we'll take this grid to a view, top view, and in this top view we will create the members using this snap node or beam command. So our first node, it is starting from 0 to 3 meter, then 1 meter. After that next it is 2 meter, 2 meter, 2 meter and 2 meter. In Y direction 4 meter, 2 meter, 2 meter. Next is 2 meter, 1 meter, 3 meter. 1 meter इकडे नाही आहे या साइड ला. The next it is at 4 meter, then next it is again 4 meter, 1 2 3 4, then this side it is 1 meter, 4 meter, then this side it is 4 meter. This is as per the plan. Next it is 3 meter. Next this complete. Okay, this 2 meter and 2 meter, 2 meter, 2 meter, and last one it is 4 meter. Okay. So here this outer periphery is completed. Now we will complete the inside also. So starting from again this top side. So at 4 meter, at 4 meter we have a beam here of 4 meter dimension. We'll complete this one section. Another point, another beam, it is at this position again of 4 meter. We'll complete this. One more it is there. So at this 1 meter and again here 1 meter. As per the AutoCAD plan you need to complete it. So we'll create it. At we complete घेतलेले ना 2 and 1 करू असं 3 and 1. Then next here this position, and then here we need to create a one member here. Let us create one beam here and then afterwards we will create. So this distance it is 4 meter, 4 meter, 4 meter, 4 meter. additional point इकडचा आहे. मी म्हटलं हा पॉइंट कुठून आलाय 2 मीटरचा. हे डायरेक्ट इकडे होतं ना आपलं. additional झालं. We'll delete this point. We'll again create a node there. Using this snap node or beam command. This is a complete beam. Okay, after that this is also not there is no any node here. We'll again delete it. त्या साइडने बघितलंच नाही गेलं ना. Then here we have the beam. Okay, this block completed, this is completed. We need to add the beam here. So we'll use perpendicular intersection from this point to this point. Okay, so let us check from block to block. This is completed, this is completed, here completed. Next to here, here, this one. Now we'll go as per this. Here we will complete one block. Okay, another at this position, from this position up to 4 meter, and from this to this. So we'll use perpendicular intersection from this position on this beam. Okay, now here we need to create one beam here, and then we'll add this one. So for that we'll go to this distance, it is 3 meter. So from 8 point you need to create it up to 3 meter, 15 meter, and then we'll join this. Okay. After that, the next position it is at directly to this beam. इकडचं झालेलं आहे, मध्ये एक टाकायचं आहे 2 मीटरला सेंटर. Okay, is it completed? इथे एक राहिल्यावर काय हे असं इथे पण बीम राहणार आहे. हा एक्स्ट्रा आहे ना. Okay, so total structure it is completed. You can check the dimensions, dimension beam, display dimension. Okay, so all dimensions are displayed there. Now it is completed. Okay. So now we'll just remove the dimensions. We'll see it in a grid isometric view. Now we'll create the column. First we'll create the bottom story, and then we'll repeat it in upward direction. So for that, first select all nodes of this total structure, and we'll use the translation repeat command in downward direction, that is in y direction, with a column height of 3 meter, sorry, in minus, we need to put it minus 3 meters, so that we will have the column in downward direction with a link step. Okay, so all columns are created here. Now from this you need to delete the column for the secondary beam, where as per the plan given, only keep the columns those are in plan, other columns you need to delete it. So for that we'll select the beam cursor, and using the beam cursor, wherever there is no column we'll delete it. So here there is no column, here also another location it is at this point, here and here. लाइन वाईज जा, इथले दोन झाले, हे दोन. नेक्स्ट इथे this column, this one, इकडचं, this one, then these two. Next it is at this point we don't have a column here, here also we don't have a column, and here also we don't have a column. Now another points it is here also we don't have a column. Okay, so all columns, that is we don't have the column in plan, we'll delete it. Okay. So now this bottom story it is completed, right? Bottom story is completed. Now we'll select the total structure. We'll use the translation repeat in y direction with a number of steps. Suppose we want a G plus 7 with a default spacing 3 meter, and let's click OK. Link step nahi. Okay, already y direction आहे, तो y direction आहे, ते already link होत जातं. Okay, so here it is completed. So geometry is completed. Now we'll assign the properties. So for property we will take prismatic section. rectangular section. For beam, suppose we have 0.23 by 0.4 for beam, we will take this point. For column, 0.23 by 0.5, add and close. So for all beams we will assign this property. So for that, select the beams parallel to X, parallel to Z, and assign to selected beam, assign it. Okay, so this property it is assigned to only beams. Now we need to select the columns, and to that we need to apply this 0.23 by 0.5 property. So first select the property, select the beams parallel to Y, assign to selected beam and assign yes. Okay, so property it is assigned. We will not add the plates here. Instead of that, we will calculate the load of slab, and that we will directly add into the floor load. Okay, so only beam and column property that we are adding here. Now material, by default it is selected concrete. Specification. So specification we need to apply it for secondary beam. So secondary beam we need to apply the release. We need to release the moments at that point. So wherever secondary beams are there we need to release the moments. So for secondary beam, that we need to create it through the specification. So click on beam. So our end, it may be start end or maybe end end. So first we will create the two type of releases, that is at start and at end. So for that, select the release location start, release type it is release, and select MX, MY, MZ, add. Similarly, create one more specification, that is releasing the moment at the end of the beam. So for this, just select the location end, release type it is release, select MX, MY, MZ, add, and here these two releases are created, start and end. So for this, what we will do, first we need to define the beam where we need to apply the start as well as end position. Okay, so first we'll select the top view to identify the correct location of the beam. So first, as per the plan given, AutoCAD plan given, you need to identify that the beam where both releases are required. Okay, so here is the beam where we need to apply the both releases, start as well as end. Another beam, that is this beam. Here is the third beam. Now we'll check in AutoCAD plan. One more, it is here. Where complete release it is required. Okay, so only these four members are there where we need to apply the both releases, because for this beam we do not have column at the start as well as at the end. So just we will check in isometric view whether all beams are selected throughout the height or not. So it is selected. So start, it is selected, start MX, MY, MZ, assign to selected beam, assign it. Similarly, select the second one, end, because all beams are selected. We will apply the second release specification at the end also. Assign to selected beam and assign. Okay. So for these beams, we'll see again in top view. These beams are the beam where there is no column at the start as well as end. So that's why we have applied the release start as well as end release at both places for these four beams. Now there are another secondary beams where the one end it is having column and another end it is resting on primary beam. So we need to identify that beam. So we'll see it again in plan. In plan we have, okay, this first beam, okay, this beam where this end it is resting on column but another end it is resting on this primary beam. So just check that this end it is which end. Just take your mouse near to that beam. So it is showing that side it is a blue color. So blue color it indicates it is end. So assign the end release for this beam. So first select the end release, select that beam and assign to selected beam. Okay, so that side it is assigned because total beam it is a primary beam. From this end to this end it is primary beam. This secondary beam, it is resting at this position. So reaction of secondary beam, it is transferring on this column at this center point. One end it is on column, another end it is again on this primary beam. So only at this point we require the release. Okay, so that release it is assigned. Similarly, another beam it is also there here. It is showing a blue color at that end. It means we need to assign the end release there. So here it is end release. Likewise, we'll check it for another beam. Here we don't have a column at this position. Okay, but this complete beam, it is a primary beam. Okay, and this one it is secondary beam. Here we have column, here we have column. This complete beam, it is a primary beam. This one it is secondary beam which is resting here, which do not have any column. So let's check whether it is start or end. Blue color indicates end, green color indicates start. So here it is again showing blue color, it means we need to assign the end release. Okay, it is end release here. Similarly, this beam, this complete beam, okay, where it is divided into these two parts because of this small portion. So here it is resting at the column, but this end it is resting on this primary beam. Okay, so for that we need to check. It is again end, blue color indicates end. So we'll assign that release. And this one, this is also resting on this beam, secondary beam. We'll check end. So it is end here. Okay, and for this beam, this part, this is completely a secondary beam. Okay, because here if you consider this beam, here there is a column, here there is a column, it means this is a primary beam. And this portion, only this much portion, okay, where there is a column, sorry, here one side column and one side it is resting on this beam. So for this we'll check whether it is start or end. Again it is a end, so for that we will assign this way. Okay, so as per the plan, now all beams, all secondary beams, they are assigned with the releases. Okay, so check in this view, isometric view, it is applied to all secondary beams. Releases are applied to all secondary beams. Okay, so now supports, next point it is support. So let's create a fixed support, add. For this fixed support, we will select all nodes at the bottom. So using a node cursor, we'll select all nodes, check it in isometric view, assign to selected nodes and assign it. Okay, now in loading, so in loading we have dead load, live load, wind load. Okay, so first we will create the cases. First case it is dead load, add. Next it is live load, we'll give the title LL, add. And last one it is wind load, WN, add, close. Now in dead load, first add self weight with a factor of -1. Another one it is member load. So in member load we need to apply the wall load. So wall load for the beams except roof. Okay, where the 3-meter wall it is resting on that beam. Sorry, the beam it is resting on the 3-meter wall. So at that point we need to apply the particular load. So here we need to calculate that. So wall it is of 0.23 thickness multiplied by 3-meter height multiplied by 18. It is the unit weight of RCC, sorry, masonry structure. So its value it is 12.42. So minus 12.42 kilonewton per meter. In GY direction we will add it here. And on the top, that is for the parapet wall. Okay, so for parapet wall we have 0.23 by, suppose consider 1.5 meter is the height of parapet wall, into its unit weight 18. So it is minus 6.21 kilonewton per meter in GY direction, add and close. Okay, so these are the wall load. So that we have created here. Another load it is floor load. So that we need to add here first we will add all the loads and after that we will assign. So for calculating the floor load, that is here, we need to calculate the pressure. So how it is calculated? Floor load, imagine that slab it is of 120 mm thickness or maybe 150, we will take 120 mm thickness, that is 0.12 multiply by RCC unit weight. So slab that is of RCC, unit weight of RCC it is 25, so it's 3. So apply it -3, that is in downward direction, global Y direction, add and close. So under dead load you need to add these 4 points, that is first it is self-weight of total structure, Y directly apply झालाय. First self-weight of total structure, then wall load on floor beam, and this wall load on parapet beam, and this floor load. Okay, so we will assign it one by one. So first self weight assigned to view. Okay, that is applied here. Now we need to apply this minus 12.42 to the okay, now we apply this load to the beam except roof. So for that we will select the bottom story. We'll create a new view for this, only for the except the roof. We'll set an isometric view and select beams parallel to X, beams parallel to Z. Okay, and apply this to selected beam. Okay, it is applied here. Now this 6.21 that we need to apply it to only top roof members, parapet members. So for that we will create a display hole structure. Again we'll take the front view and we'll select only top story beam. Okay, we'll create a new view for this and we'll check it in isometric view, sorry, in top view. So in top view we will select only the exterior beam where parapet it is there, only the parapet beam. So manually we will select it and we'll assign this load to selected beams, assign it. Okay, display whole structure. So you can see it clearly that this blue color, that wall load it is applied on this parapet beams only, and here for raised beams it is minus 12.42. Now we'll assign this floor load. For that we need to select the range in Y direction, X direction and Z direction. So first let's check the dimensions. Okay, first we'll check the dimensions using the node to node distance. So this is the width, that is 15 meter. This 12 point, it's not 12 point exactly, we'll check it here. That is a, this dimension it is actually oblique dimension. So here it is 12 meter and the height is 24 meter. Whether it is display whole structure, 24 meter is the total height. Okay, so we'll define the range accordingly. So in Y range 0 to 24, X range in X direction 0 to 12, and in Z direction 0 to 15. So now we'll modify it and you can see it in results also. This floor load it is assigned to all floors here. Okay, in top view also you can check it this way. Now lie load. So lie load we will consider, for example, that is 5, maybe for residential building from 2, 3, 4, 5 like that you can assign. So we will assign like suppose -3 kilonewton per meter in GY direction, add close. Okay, you can apply lie load differently on terrace and on other floors differently. Here let us assume that this load it is common to all floors, this live load. So we will assign it to this minus 3 kilonewton load to all beams. Actually this load should be added, it is not a member load. Under this live load it should be a floor load, and on that floor we are applying that load minus 3 kilonewton per meter square in the same range, that is 24. In x direction it is 12 and in z direction it is 15. Okay, add and close. So here is the live load on all floors. Okay, now for wind load, first let us create the wind definition. So for that select the code, as it is a RCC structure. So for that you need to select the code first. RCC आधी सिलेक्ट नव्हता केलेला का रे? ते आपण तिकडून सिलेक्ट करत राहतो ना, त्याच्यामधून सिलेक्ट करायचा राहतो आधी कोड. मटेरियल मध्ये कॉन्क्रीट करायला, मटेरियल मध्ये जरी नाही केलं ना तरी नाही होणार ते. IS 456 इथे तो यायला पाहिजे लोडिंग मध्ये, डेफिनेशन मध्ये तो कोड 456 नाही ना, IS 875 येतोय. अरे विंड लोडचा तोच आहे ना, सॉरी विंड लोडचा तोच आहे ना, राईट. तो डिझाईन साठी 456 आहे, राईट. So it is close, add. Now here generate 2015 structure type rectangular clad. Height it has taken, interval that we need to edit it, that is 3 as per the building given. Select the city Nasik. It's 24 na total height. Total height is 24 with the interval of 3 meter. Select city, it is Nasik. Risk coefficient factor, right now we will just assume it 1 accordingly. Click on OK. We need to define the another parameters for rectangular building. All dimensions it has taken already. OK. Add. Exposure factor, right now assume 1. Add, close. Assign this exposure factor, assign to view, and yes. Okay, so wind intensity it is created. Now we'll apply it in this load, wind load. So for that click on add. Select the wind load in windward direction with a factor of 1 and -1. Add it. Same in z direction with a factor of 1. Add, and with a factor of -1. Add, close. Okay, so all these 4 loads are created, 4 pieces. Okay, on all 4 sides it is applied there. Now we'll create the load combination, auto load combination as per IS 456. IS 456 table number 18. Okay, so click on generate loads, it is generated. Add, close. All loads will be generated here, load combinations. And now simply run the analysis. For that define the command perform analysis. Here these are the different types of analysis that can be created, that can be done in STAAD PRO. So right now we are performing a basic simple analysis, perform analysis. Add, close, and run the analysis. Okay, so done. Now in design, select the parameters. First select the code IS 456. Okay, select the parameters, that is FC, FY main, FY6, max main, sec, and minimum diameters, minimum size required for the main and secondary. Okay, now we'll define all these parameters. Let us consider concrete, it is of grade 30. Add. Consider main steel of 550. Add. Secondary steel 415. Maximum diameter for the main steel it is 32. Maximum diameter for the secondary steel it is 10. Minimum 12 for the main and minimum 8 for the secondary. Okay, Assign all these points, assign to view, because that we need for total structure material, it is common. So assign to view for all points. Okay, it is assigned. And now no, we need to define the commands: design beam, design column, and take off. This beam that you need to define only for the beam, because here now STAAD Pro will consider which one it is beam, which one it is column. Right now all are simply members. STAAD Pro consider vertical member as a beam, horizontal member as a beam. Okay, so now we need to tell the software that which one is beam and which one is column, now in from structural point of view. Okay, so first select the beams parallel to X, parallel to Z, and design beam that we have already selected, beams are selected, assigned to selected beams. Now deselect all these beams, select design column, select parallel to Y and assign to selected beam. Now it will design the beam as a beam and column as a column. Okay, now simply run the analysis. Okay, and here you can check all these results. This is the deflection. Just scale it out. Fy, shear force diagram, Mz, beam stresses that you can click. If you want to see for any particular beam, you can double click on that beam using beam cursor. Just double click it. You can see the property starting from the geometry, its node x, y, z coordinates. Okay, its property, the property that we have applied, loading as per the total load cases. And here in shear bending, you can select, this is the bending moment diagram. Bending Z means bending moment mz for that particular member, and for shear force diagram this shear y. Okay, similarly deflection in y direction, you can check. In x direction this is the axial displacement, in y direction this is the deflection of the node, and at the center maximum deflection. And here is the concrete design reinforcement details. Okay, and in plate, as we do not have any plate, so right now it will not show any plate results. Okay, नाही नाही टाकली तरी काही नाही, तुम्ही फक्त स्लॅब लोड टाकून द्या.